So next one is runway length. It is the length of runway under the following assumed conditions. One is airport altitude is at the sea level. Temperature at the airport is standard 15 degrees Celsius. Runway is leveled in the longitudinal directions. No wind is blowing on runway. Aircraft is loaded to the full loading carrying capacity. And route temperature is standard. Corrections for elevation, temperature and gradient. The basic runway length is discussed earlier is for mean sea level elevations having standard atmospheric conditions. Necessary corrections are therefore applied for any change in elevation, temperature and gradient for the actual site of constructions. Correction for elevation. As the elevations increase, the air density reduces. This is in turn reduces the lift on the wings of the aircraft, and aircraft requires greater ground speed before it can rise into the air. To achieve the greater speed, longer length of the runway is required. ICAO recommends that the basic runway length should be increased at the rate of 7% for per 300 meter rise in the elevations above the mean sea level. Corrections for temperature. The rise in the airport references temperature has the same effect as that of the increase in the elevation. Airport references temperature is defined as the monthly mean average daily temperature, that is TA, for the hottest month of the year plus the 1/3 of the difference of the temperature TA, and the monthly mean temperature daily temperature TM for the same month of the year. This is for aircraft reference temperature. ICAO recommends that the basic runway length after having been corrected for elevation should be further increased at the rate of 1% for every 1 degree Celsius rise of the airport references temperature above the standard atmospheric temperature at the elevation. Check for the total corrections for elevation plus temperature. ICAO further recommends that if the total corrections for elevations plus temperature exceed 35% of the basic runway length, their correction should be further checked up by conducting the specific studied at the site by model test. Corrections for gradient. Steeper gradient results is greater consumptions of energy, and such longer length of the runway is required to attain the desired ground speed. ICAO does not recommend that specific corrections for the gradient. FAA recommends that the runway length after having been corrected for elevations and temperature should be further increased rate of 20% for every 1% of effective gradient. Effective gradient is defined maximum difference in elevations between the highest and the lowest points runway divided by the total length of runway. Basic elementary of the runway is like structural pavements, shoulders, runway strips, a blast pad, runway and safety areas, stopway of clear way. Structural pavements, it is the paved area whose width is designed to ensure the safe operating surface. It supports the airplane load. Shoulders, the shoulders be adjacent to the structural pavements, which is designed to be resist the erosions due to the jet blast, and the accommodations, maintenance and equipments and the petals. Runway patrols, the runway strips, it includes the structural pavement, shoulders and the area that is cleaned and the graded. This is the area should be capable of supporting fire, crash rescues and snow removals of equipments. Blast pad, the blast pad is the area of design prevent the erosions of surface adjacent to the ends of the runway, which are subjected to repeated the jet of blast and maintain the excessive ground maintenance. The areas are either paved or planted with the turf. Runway geometric designs, factors considered in geometric designs of runways: runway length, runway width of the length of the safe areas, safety areas, temperature, transverse gradient, longitudinal effective gradients.